So yeah, thanks everyone for coming, especially so late in the day. I know everyone's tired, but hopefully Jennifer's passing out some stickers, and hopefully that'll make up for it a little bit. So my name's Derek Curry. I'm an artist and a PhD candidate at the University at Buffalo. My dissertations focus on agency within algorithmic data aggregation and processing systems, and I'm yes. Oh, I'm sorry. So my PhD research focuses on agency within algorithmic data aggregation and processing systems, and I'm specifically looking at systems used by intelligence agencies and algorithmic trading systems, algorithmic trading bots.
And thank you everyone for joining us. I know it's the end of the conference, but we're excited to have so many people here. So I'm also an artist. I'm Jennifer Gradecki, and I'm a PhD candidate at SUNY Buffalo as well, but I'm in visual studies. My research focuses on how information is used as a source of power in intelligence agencies. And one of the things that I'm currently working on is getting the FBI file for Steve Kurtz of Critical Art Ensemble. Tactical media came up in one of the last talks, so I'm sure some people are familiar with this. And I plan to analyze the redactions with him. But the FBI has been dragging this whole thing out for almost a year already, and they've been giving me a lot to write about in terms of information and power. But today we're going to be talking about the crowdsourced intelligence agency, which is an online application that's designed to replicate some of the known strategies that intelligence agencies use to evaluate open source information.
So the application itself is an artistic research project, and all of the findings and source code we produce are going to eventually be open sourced. So crowdsourcing works differently here than it does in marketing, where ideas are usually sourced from a crowd of people and nothing is given back in return. The idea here is that the crowd helps produce information that they can then use themselves. We initially launched this project in August at the Secret exhibition at the Science Gallery in Dublin, who also helped fund the project. If anyone's going to Dublin anytime soon, the show's going to be up until August 11th. So what we ideally want from this project is to give people tools to help understand how certain types of data valence work. So, for example, it could be useful to know how these automated systems make decisions if you happen to be an activist or somebody that might find yourself targeted by these collected all systems. And also to show how these systems fail, because none of them have a 100% success rate. And it's actually just really interesting to see why some people who are completely innocent are swept up, and other people who are doing something wrong, or they get by for a long time without ever being detected. And to provide yet another response to people who say they aren't concerned about surveillance because they have nothing to hide. The OSINT technologies we're looking at don't detect criminal activity. They detect patterns in language, which happen to be statistically linked to the language of known targets. And when these language similarities happen to cause system failures that are either interesting enough or spectacular enough, they make the news. So here's two notable examples. In 2012, 2 British students were detained by the U.S. Department of Homeland Security for posts they made on Twitter. And during the trial of the Boston bomber, when there was ample physical evidence linking Sarnav to the crime, the Twitter evidence presented by the FBI was exceptionally flawed. A photograph of a mosque in Grozny was used as the background of Sarnav's Twitter page, and it was incorrectly identified as Mecca. Song lyrics and jokes from the television show Key and Peele were incorrectly marked as evidence of terrorist activity. In this case, the Twitter evidence actually hurt the government's case. It didn't help it. They still won, but...
Okay, so I'm going to give just a very brief walkthrough of this first phase of the project. It's a video walkthrough, and I'll just narrate through it. So participation begins when a user navigates to the web app and then signs up via their Twitter account. Here we see the agent's profile page, and they're navigating to the social media monitor where individual tweets can be rated. First, you see the tweet's metadata, and you can toggle for more information. Then you see the tweet itself. And here's where the agent rates the tweet as safe, threatening, or flagged for follow-up for review by other agents. They can also leave a comment about their analysis if they want to. And once submitted, the agents receive a confirmation page informing them that a tweet has been sent to the Twitter author with the updated tweet record. The Twitter author is notified with an automated tweet, and the content varied in each of these tweets, showing different details about the rating, but they all include a link to the record. And when that link is followed, it takes them to a greeting page that notifies them that their tweet was rated, and the metadata now contains the rating that the tweet was given. There's also information about the project that they can look through. And if users log in and become an agent, their profile page will contain both the tweets that they've rated and the tweets that they've authored that have been rated. And at the top, you can see the tweets that they've authored that have been rated. And now that they're an agent, they can debate the ratings of other agents. So here we have Derek's tweet. It was rated as a threat. And Derek can disagree here, and then he's able to defend himself against this rating. So one of the things that we were really interested in during this phase of the project is the issue of accountability. Intelligence agents are typically not held accountable to the people that they surveil, so we wanted to change that relationship while opening up some aspects of open source intelligence gathering and processing. Logging into the app from Twitter is currently banned, which is unfortunate because this prevents the feedback loop that I was just discussing. So 1 week into the project, we were banned from sending automated emails on Twitter, and then about a month into it, we were banned from allowing users to log into our app via Twitter. So for those of you who have developed with Twitter, you might be familiar with this already. Twitter doesn't tell developers why they're banned, so we have to read through several legal documents, try to figure it out, change the app, and then request a reinstatement. So we're currently in the process of working on that. But this phase of the project can still be accessed via a terminal at the Science Gallery in Dublin, which Derek explained earlier on. So it continues just without some of that interactive Twitter activity. And now we're going to move on to the second phase of the project, which is called Agent Bays.
So this is up and running right now. This isn't going to be banned. It's not working through Twitter's API, at least not the signing in part. So Jennifer's passing around manuals for agent bays. And if you have a computer or a mobile device, you can actually log on to this and follow along if you want. Otherwise, the addresses on the stickers that we passed out, and if you didn't get a sticker, there's some up here. Yeah, and the address is also right there. So I'm going to walk you through how this works. So this is the home page for the Crowdsource Intelligence Agency. And right on the front, you see a button that says Meet Agent Bays. If you click on that, it will tell you who Agent Bays is and a little bit about the project. Then you can click Review Agent Bays. And you're brought to this page that has tweets that were classified by Agent Bays. And so you can see the decision that this algorithm made. and decide whether or not the decision it made was correct or not. You can also filter the tweets. So if you want to sort them by whether or not they were seen as suspicious or not suspicious, you can do that. Or you could look at tweets that have already been reviewed by other people, and more than one person can review these tweets. So if somebody's already reviewed an agent-based tweet, you can disagree with their evaluation as well or support them. But let me click on one of these. So this is what you see. So this is actually just the first one that's in the queue. They're ordered. They're in the queue when you first get there. They're ordered by tweets that haven't been reviewed yet. So this one hasn't been reviewed yet. An agent base decided that this tweet was suspicious, and then this is the metadata from the actual tweet itself. And then here is the actual tweet. And then you have the option to agree or disagree with agent Bayes. And I don't think that this is actually a threat. I think that this is just somebody saying they were getting DDoS'd. So I'm going to disagree with this. And then you can choose the features of the tweet or the metadata that helped inform your decision. So this is words in the tweet. Let's see, is there something about this person's name? Global gaming. Yeah, so there's really nothing about this that is suspicious. Gaming is not especially safe, so and I'll submit my review. And the page will reload and you'll get a thank you notice. Thank you for evaluating this. And if you scroll down again, you can see that your review has been added to this, so you disagree, and then you can see the informative features of the tweet that helped with this decision making. Let's start at the beginning. No, it didn't. Okay.
Okay. So Agent Bayes addresses the practice of automated open source intelligence gathering, or OSINT, which includes scraping data from social media posts, news and academic articles. Of course, we're focusing on Twitter posts. And OSINT has been largely uncontroversial in public discussions, although probably not in this room, because the data is already publicly available. And while there have been numerous stories about mass surveillance strategies, what is done with the data once it's collected is rarely discussed, including whether or not this approach actually improves the detection of threats to national security. So we set out to investigate and raise questions about these socio-technical processes. Because intelligence techniques are secretive and classified, studying them requires a certain amount of speculation based on incomplete information or connecting the dots. Our primary methods are document analysis and artifact construction. We've heard a lot of other examples of that this weekend, so that's been really great and informative for us. So based on document analysis, we know some of the information going in. We know that they're classifying things in certain ways, and they're using certain technologies, so we can ground our speculation in a practice-based understanding. So we start with a document analysis to construct a mosaic of information, and our information sources include, of course, Freedom of Information Act request files, like the Analyst Desktop Binder from 2011. This was released by the Electronic Privacy Information Center, and it shows us some of the techniques that the DHS has used for social media monitoring. And these are some of the infamous keywords. We've also looked at ethnographic reports. This is a dissertation on information sharing, that's a tongue twister for some reason, at the National Counterterrorism Center. And one of the interesting things that it showed is that there's a widespread fear of not sharing enough information, while simultaneously they are overwhelmed with too much information. Of course, we're also looking at leaked documents. So this is the Snowden doc on Lovely Horse, and it shows some of the Twitter accounts that are targeted by the GCHQ. And then in their problem statement, which I have included an excerpt from, you can see that exact same concern over too much information and then the desire to automate open source information processing. And we've also been looking at technical documents. This is a monograph that was $500, and as a grad student, I was able to get my institution to buy it for me, so this is largely inaccessible. And it details industry standards of next generation information access or automated information processing systems.
So artifact creation is the next stage of our research, and it begins wherever there are gaps in information left by our other research methods. Hopefully those other research methods have provided some boundaries that we can work within to create an artifact that then fits the contour of the missing pieces of information. Ideally, the process works like an algebraic equation, where you have some known technology and a specific outcome, and then you can just solve for X. But most of the time, there's more than one missing variable or other obstacles in the way, so it hasn't ever been that easy for us. In practice, this usually just means a lot of trial and error. You know the result that they were getting, you know some of the technology, so you just keep building things until you get close to the mark. It's actually really nice to see. We saw several people who are actually working this same way here, and it's I found relatively rare. So if anyone has any insights into practice-based research or artifact creation in this way, would love to hear them. Our method is based primarily on Philip Agree's critical technical practice and the critical engineering manifesto, which is, I've already heard that mentioned a couple times here at this conference. So it begins with an immersion into an analysis of the language and practices used by the group that created the technology we're studying, especially the metaphors that they use. Then a technological artifact is constructed following the procedures and tools that we know are being used by people who build these systems. And luckily for this project, much of the technologies used by intelligence agencies are already open source and available to the public. For example, the Haystacks watchboard that Jennifer showed you a minute ago, and also pictured right here, was written in Python and uses the Flask micro framework, so that's what we decided to use for the CSIA. These systems are also typically built by government contractors, so it's kind of interesting that they borrow so heavily from the open source. It reminds me of Sergei Elanikov, the Goldman Sachs trader who is accused of stealing information that can manipulate the world markets. I don't know if anyone's heard about this case. When it went to trial, it turns out that what he stole from Goldman Sachs was actually open source code anyway. So apparently the open source is contributing to all sorts of interesting projects. These systems also include open source language processors and open source machine learning classifiers. And Bayes' theorem is the most common formula used by intelligence agencies for establishing the probability of an event. And there's many open source classifiers available that are based on Bayes' theorem, which if you haven't guessed by now, this is where we got the name Agent Bayes. Most next generation information access systems use a Bayesian classifier, and the Bayes algorithm is it's actually a procedure for inverse probability or making predictions with incomplete information. You don't have to know everything to use Bayes' formula. Naive means that it assumes that all features are independent of each other. The algorithm does not need to understand causality, nor does it infer it. Naive-based classification is nothing more than comparing the features from a test case to features in a model or classifier. What this means in our project is it creates models for what is suspicious and not suspicious as a tweet, and then it looks for similar features in the new tweets that we feed into it. Both the words from the tweets and the metadata from the test data that are fed into it become weighted vectors in the classifier. So what this means for you is if you happen to have a similar speech pattern or a similar Twitter handle or description of yourself to a known target, that you could find yourself on a watch list somewhere. So don't go tweeting anything from Key and Peele. And here's the supervised learning workflow from our algorithm. It starts with the Twitter data, which is collected through Twitter's API, and then it's manually labeled as suspicious or not suspicious, and tweets that are too ambiguous to be used are just discarded. And then that becomes the training set that's where features are extracted from. And extracting vectors or extracting features means breaking up all of the elements of the tweet into discrete pieces of information, and in our case, this includes the metadata. And then some of these words, so it's broken up into individual words, and then some of these words are just filtered out because words like and, is, the, they don't mean anything. And ideally, as this process goes on, you filter more and more words out when you decide that you don't want those to become vectors in your system. Then the label vectors are fed into the Bayes algorithm, which creates a model or classifier to test new data against. The features of the new tweet are then compared to the vectors of the models of suspicious and not suspicious tweets, and a prediction's made. And then here are the vectors that were made from our thin corpus. We need to keep building this, and the more and better data you have, the more accurate these things get, although there's a problem with overtraining and having too much data, which I'll talk about in a minute. So far, our corpus contains mostly tweets that contain the word DDoS, and we did this because it's fairly common to find people making a DDoS threat on Twitter, so it was a way to ensure consistency among all of the data that we get, and yet still find enough tweets that are actually making a threat to label them. So these are the top 10 vectors for DDoS, and you can see that they're not Boolean. They're based on either the presence or absence of a term, and that presence or absence could indicate either suspicion or not suspicion. So it's actually a weighted decision matrix. And I have a terminal version of this here that we can play with. So so you can see the weighted vectors up there. So you could say something like, I like to DDoS with InfoSec. And Agent Bayes believes that this tweet would be suspicious. On the other hand, news is being DDoS. And that tweet wouldn't be suspicious. So it's right now it can usually filter out news stories. That's one of the problems that you end up with is that news stories are often about bad things happening. So you have to find a way to account for things that are actually these bad things and things that are just stories about these bad things. Where's my camera now?
Okay. So to train Agent Bayes, I looked through thousands of tweets that were swept up based on the DHS keywords used to automate social media monitoring. So we were looking for the words DDoS and attack so far. And to build this training corpus of categorized tweets, I followed the procedure that you're familiar with by now. So I analyzed each tweet and its metadata, I labeled each tweet as suspicious or not, and I had to throw out hundreds of tweets because Twitter bots create information glut. So for the term DDoS, there were 2 bots that flooded Twitter with hundreds of posts using keywords and then just posting links to books. And for me as an individual agent, this made a random sea of noise, and it actually buried the meaningful tweets. On the other hand, this was nothing for our algorithm to process. I found it incredibly difficult to decide if a tweet was suspicious or not, and this was partially because I hated taking on the role of being an analyst. but it was also because I followed the known tendencies of intelligence agencies rather than trying to use my own perspective. So for example, I know that intelligence agencies err on the side of caution, and that the goal since 9/11 is to share all the data, so they're afraid that they might miss something. I also looked for references to groups that I know have been targeted by intelligence agencies, so Occupy, Anonymous, Anti-Sec, Snowden, Assange, Greenwald, Miranda, I can go on. And we also know that intelligence agencies are against the widespread use of encryption. The government recently called for exceptional access or front door access to cryptographic keys. So it was safe to assume that people that were really vocal about encryption would be targeted. And lastly, we know that sarcasm, parody, and pop cultural references may not be recognized by agents, as we saw with the FBI's misinterpretation of the Boston bombers' tweets. So these were some of the things that I kept in mind as I rated hundreds of tweets to create our corpus.
So we have some preliminary results. This project is really just started, but we have enough data to make graphs. So this is a bar graph for the tweets evaluated by visitors of Science Gallery Dublin. So these are people that went into the gallery at Trinity College and used the terminal from the picture that Jennifer showed you earlier. And all of the people that they're evaluating are targeted. So the tweets that you see when you go into the Science Gallery Dublin are tweets made by followers of Science Gallery Dublin. So this is at least ostensibly like an inside group thing. You have people that visit the gallery, or labeling people who are fans of the gallery. So there shouldn't be huge cultural differences or anything. And so you can see that out of 9,190 tweets, there's still about 13,000 that need to be rated. Under 2,000 of them are actually labeled a threat, while roughly 6,500 are considered safe, and there's another small percentage that are flagged for follow-up. If an agent flags something for follow-up, another agent can come in and label it. So there might have been more that were initially flagged for follow-up that have been taken care of. What's interesting is we can compare this ratio of threat to non-threat to Agent Bay's labeling tweets as suspicious or not suspicious, and it, at least on the surface, it looks like they're similar, and it turns out that they're actually surprisingly similar. So Science Gallery visitors identified 22.11% of the tweets as threatening, while Agent Bay's identified 21.49% of the tweets as threatening. So apparently you have a slightly better chance with the algorithm of getting away with something than you do with people who go to Science Gallery. But are they making the same decisions? So the ratio is the same, but do they agree with each other? And not really. I mean, sort of. So of all of the tweets that were labeled by visitors of Science Gallery Dublin, Agent Bayes agreed with those visitors 64.98% of the time, which would be a failing rate for a system like this. But we also didn't fine-tune that algorithm either, so we're still in the process of tweaking it, so we can improve upon this. So this is like the baseline. So some of the things we've actually learned through the process, there's some problems that we know are going to come up because they're just problems that you usually have to deal with when you're using machine learning algorithms. One of them we found already, and it's called overfitting. Overfitting occurs when a statistical model describes random error or noise instead of an underlying relationship, and this is the result of a bad training corpus. So a corpus that contains identifying information that you don't want or unclear instances of information that you do want. So while the algorithm itself is naive, the data scientists using it, they have to have a very clear idea of what they're looking for and what they need to filter out when they're training their algorithm. So in this way, it's a lot more like an art form than a science. So to give you an example of how overfitting works, these are the vectors for a naive Bayes classifier that we made from unfiltered tagged data from the visitors of Science Gallery Dublin. And you'll notice that number, was that 4 up there is Guinness. So this Guinness is one of the vectors that would identify suspicious behavior based on this algorithm. So I looked at the underlying data. I looked at the data set that this was trained on, and it turns out that in about two-thirds of the times that Guinness is mentioned is actually part of a person's name and not the beer. And it wasn't the same person either. It wasn't like some guy named McGuinness is going on doing all this bad stuff. It's a bunch of different people. So this would be something that would need to be filtered out. But this is sort of an indication of where problems in the real world could happen. So here's a hypothetical situation of how a training corpus could contain erroneous data. The FBI knew that Sarnav was guilty, the Boston bomber, so they assumed that his Twitter posts were an indication of guilt, when it turns out that he tweeted about all sorts of things. We haven't found any evidence to either prove or disprove that they were using NGIA systems to surveil Sarnav specifically, but we can imagine a situation where Twitter data from known terrorists is fed into a system, and other Twitter users who watch the same television shows or listen to the same music begin to be targeted without the agent knowing anything about their background. If intelligence analysts can't identify jokes from an American television show, can we really trust them to identify aspects of cultures or subcultures that they might be even less familiar with?
Culturally, we're in the early phases of understanding contemporary forms of data valence and the appropriate tactics of resistance to them. We take the position that a critical socio-technical awareness of how contemporary data valence functions is the first step toward any kind of resistance. By replicating known data processing techniques, CSIA allows for a practice-based awareness of data valence and exposes potential problems and oversights inherent in the process. But we're not only replicating what intelligence agencies do in order to study them. By opening up these processes for all to participate in and see, we're also changing the relationship between intelligence agents and their targets. Intelligence agents are typically unaccountable to the people they judge. People who are profiled cannot usually see the processes behind how they're categorized. But by giving users first-hand experience with how social media surveillance works, we hope to provide them with the means to navigate the security apparatus, to choose if they want to evade algorithmic capture, jam the system with too much information, or find another mode of engagement. So the CSIA not only opens a debate about the effectiveness of surveillance techniques, it also enables users to reflect on how they want to engage with it. Thank you very much. So we'd love to hear any comments, questions, feedback. And I also just want to mention a big thanks to Sarah, Erica, and Amelia for putting this together. This has been really amazing for us and great to see all of your work. So we look forward to hearing your thoughts. Yes?
So one of the fields that I know where this sort of surveillance goes on is the advertising technology industry.
Right.
Where people are doing social listening to try to understand sentiment regarding a product.
Yeah.
And there are libraries that are out there that are sentiment analysis libraries, which essentially come with a pre-configured, pre-designed corpus of words that are supposed to match up against whether people like something or not.
Right.
And the person who I know who I've talked to who does this work says basically, yeah, we use the algorithms, but if you really want to know what's really going on, the analyst reads as many of the actual things as they can.
Right.
Because especially in a Twitter world, you know, the message is so short that you can't really contextualize it very well. Mm-hmm. And they end up reading as big a sample as they can imagine doing for their client who sells consumer goods, right?
Right.
Not who's looking for chaos, but who's looking for, did they like their pizza or not?
Right.
So, I guess the part of the question, if I'm going to put it in the form of a question, is, how much of the analyst's work is automated tools, how much of it is crowdsourced stuff, and how much of it is one domain expert looking at a very narrow domain day in, day out?
Yeah, I think that's a great question. It's not only a great question, but it's also really, informative, because Derek actually has a lot of experience working with sentiment analysis in relation to finance, and they're using some of the same techniques.
They are, yeah. There's actually, so within financial sentiment analysis, when they started, they were using corpuses created by psychologists for human sentiment. But then there was a corpus made by two researchers, Logram and McDonald at the University of Notre Dame, that constructed a word corpus specifically designed for finance. And that if you use that corpus, you can actually get a much more accurate judge of financial sentiment. But within how this actually works with intelligence agents is usually these automated systems label things as suspicious or not suspicious, and then it's given to an analyst to make the final decision. And Jennifer would know more about how that decision-making process happens than I would.
Right, yeah. Well, the one thing that I don't know, I can't give a percentage. I wish I had that information. If anyone has any information, I would love to have it. But I brought this slide up because this is an example where this is multiple different data feeds. So the next step in our process is that we'll start creating watch lists of these suspicious people, so people can see how that process is done. So we haven't gotten to that part, so I don't have that much of a practice-based understanding of it. So I can't say, this amount is automated, this amount is, done through. But in my experience of, taking on the role of an agent and analyzing these things, when I was making that judgment, I did look outside of Twitter. But there is also a lot of information within Twitter itself. The metadata itself is actually very informative. So the name of the user, the description that they give is sometimes can contain a lot of information about their interests.
The location.
Yeah, something like that. Although they, in the textbooks that I was looking at for intelligence agents getting training, they, claim to not be profiling, although, we all know that that's not the case in practice. But that's what it says in, in the textbooks, or that's supposedly how they're being taught. But, yeah, but that's a great question.
I noticed in your list of informative features that high up there was DCU, which is a rival university to Trinity College in Dublin.
Huh.
Do you worry that the people who are doing the labeling in the science gallery are possibly inserting some biases into it?
Definitely. Yeah.
It's the next one.
Oh, was it? Okay. Yeah, do you want to talk about this? Or do you want me to?
Yeah, the biases are there for sure. One of the interesting things, I guess maybe to speak to we didn't really talk about the aesthetic aspect of this at all, but this is an artistic research project. So the aesthetic for this work is that if you use this for any length of time, you're going to be presented with a tweet that you fundamentally disagree with based on your own personal politics or something like that. And then you're faced with this decision of well, is this actually a threat, or do I just hate this person,
or also the opposite way. So it was really hard for me. I kept finding people and being like, oh, that person sounds really cool, I want to follow them. And I'm like, no, I'm not on Twitter, I'm an analyst,
Right.
So there was a lot of bias for me that I had to constantly take out of my own perspective. And we were at the Science Gallery at the opening, and we got to talk to a lot of people who were engaging with it. And some of them took it very seriously and were actually really kind of frustrated by the process, like, this isn't that much information, I don't know how to deal with this. And then there were some people that were not taking it that seriously. But the interesting thing about crowdsourcing is that you have so many of them. We have 9,000 so far, that we ended up with these very similar, in the end, a very similar statistical ratio of things that were considered threatening or not. So, yeah, I think that's a great question about bias, and that's definitely something that we know is already there in the intelligence agencies, in the agents.
Yeah. For our system, specifically will filter those things out. Theoretically, if you get a large enough crowdsourced data set, it'll sort of even out anyway. This won't happen with the corpus created at Science Gallery because it's too specific to the location, and that's why you're getting things like that. But when we actually produce this to give it away, we're going to manually look at all of this stuff and make sure that it was accurate before we include it.
Yeah, before we open source it. Did you want to mention MIT at all? Because they're doing the crowdsourcing at IARPA.
Oh yeah, IARPA is doing some really interesting crowdsourcing terrorist watching stuff for real. And they, at least in what they presented, they've got some pretty substantial results from these systems, although they're not using naive Bayes algorithms. They're using support vector machines and things like that. So it's it's a lot more sophisticated than what intelligence agencies are using. But it's interesting. I have a question. Am I allowed to ask a question?
I don't know why not.
So this project sort of just got started, and I know a lot of people here are activists and would be people that would be interested in using any tool that we could make from this. Would there be anything specifically that you would want to see? The one idea we have right now is to sort of put like an online evaluator, so you could, like the terminal, so you could just type in your tweet before you send it off and see, what it would be rated. But is there anything else that would be?
I would love like a tool that I could just type in my handle and then it would tell me if any of my shoes were flagged.
Yeah, that's a good idea.
Oh yeah, that is a good idea. We could totally.
But I think
do that.
the API only goes back like a couple weeks or something. Like, or you have to have special access to get like the full.
Yeah,
we
we
don't
definitely
have
don't have the full
those.
corpus, although
actually
Twitter's API is only one way in, so you can surface scrape and go back much further.
I'm just taking notes on this, so yeah, the handle, that's a good idea. So any other questions, comments?
If you think of any other ideas, there's a contact button on the sticker.
Yeah, and if you guys didn't get stickers, the web address is on here. If anybody, I think I handed these out already.
Oh, and we didn't
Yeah.
put our contact information up there.
Well, so the website is on here, and then there's a contact button on our website, so you can just reach us that way. Thank you very much.
So we're finishing a little bit early, but I hope you don't mind. Thanks.